frequency distribution with data classes. So we're going to have a set of data here. We have just some raw data. Doesn't really matter what it pertains to, and it's sort of randomly set up here. The first thing I want to recommend is that you always sort your raw data before making a frequency distribution. It makes it a lot easier to see what you're working with. So here's the data raw on the left side, and here it is sorted. And you can see, we can clearly see now that the lowest value is 1 and the highest value is 25. Now, if we were to set up a regular frequency distribution, your values would be on the left side and frequency of those values would be on the right. And you can see here that this works, but it gets really cumbersome and you have a lot of these zeros because we don't have these values. This is a pretty small data set, and if it was much larger, it would get very unruly. So what we really need are data classes. But how many data classes is the question? Most data can accurately be displayed using somewhere between 5 and 15 classes. 5 is considered a minimum, and 15, possibly as many as 20 if it's a really large data set. How many classes you use depends on the data, how many values are in it, and how it's spread out. So if we look at the sorted data again, we can see it goes from 1 to 25. We know that we could probably get away with just the minimum of 5 classes in here because it divides in pretty evenly. So we've decided on 5 classes. Now we calculate the class width. The formula is to take the largest observation minus the smallest observation and divide it by the number of classes, which we have decided is 5. So our largest observation was 25, our smallest was 1, and we divide it by the number of classes 5, and we get 4.8. Now the rule for setting up classes is to always round up to a whole number. So in this case, we're going to round up to 5 and our class width is 5. When we say round up, even if my answer was 4.1, I would round up to 5. So just always round up to the next whole number. Now all we have to do is take our sorted data and count how many data points fall in each class. So we've set up the classes 1 to less than 6, 6 to less than 11, and so on. One key feature here is we do not set it up 1 to 6 and 6 to 11 because then 6 would be in 2 classes and we wouldn't know where to count it. So you have to make sure that you don't have any overlap in your classes. So this 1 to less than 6, we simply count how many data points are in that class. And we have 1, 2, 3, 4, 5, 6, 7 fall in that class, so our frequency is 7. We just do this for each class. Then we total it and then count how many observations are in our data set just to make sure we didn't miss any. Another way you could display this, here's the original on the left. Another way to display it would be to use the mathematical symbols instead of the words. And you notice the last class, instead of saying 21 to 26, we just said 21 and over. In this case it didn't matter, but sometimes you might have a data set where the top value, let's say in this case, instead of being 25 was 27, but there was only one of them. And you really didn't want to go to 10 classes or even 6 classes. You really wanted to keep a nice even, nice divisible number. So we would just put 21 and over and put it in there. And that is how you use data classes.